Once we've drawn our triangle, what we need to do next is work out the distance for the horizontal black line and the vertical black line. So the first thing I'm going to do on the left-hand side here is draw a vertical dotted line down from the end of the black to the x-axis and at the other end. And I'm going to read off from the scale what those two values are. So looking at the scale, I can see the first red line is at 0.5 seconds and the second is at 13 seconds. So now we need to do the sum. 13 take away 0.5 equals 12.5 seconds. Next, I'm going to do the vertical line. So the vertical line starts here at 5 and it ends here. Excuse my wonky line. So reading off the y-axis, I can see that this is at 6 centimeters cubed and this one up here is at 15, 16, 17, 18 centimeters cubed. So this sum will be 18 minus 6, which is going to equal 12 centimeters cubed. And the next stage is to do rise divided by run. So the rise is 12, so the vertical distance is 12, the run is 12.5. Now it's really useful in this sum to include the units, and I'll show you why in a second. So that was 12 centimeters cubed and that was seconds. Now when we do that sum on our calculator, we get an answer of 0.96. Now you must have a unit in an exam question when you're doing this type of calculation. And we can look at our sum to work out what the unit will be. We have divided centimeters cubed by seconds. So the unit is actually centimeters cubed divided by seconds. Now, of course, we wouldn't write the unit like this. How we write it in chemistry is, I'm just going to rub that out. We show what the units were. We write centimeters cubed slash seconds, and that slash means divided by. You can also write it centimeters cubed to the second minus 1. And that would be our final answer for the rate of this reaction at 5 seconds exactly.